In today's video, we are learning Matplotlib Basics, the foundation of data visualization in Python. If you are entering the world of data analysis or data science, this library is absolutely essential. By the end of this lesson, you will understand how plotting works in Python and why Matplotlib is such a powerful tool for visual storytelling. Let's begin with the very first step, importing the libraries. So first of all, we will be importing Matplotlib and Seaborn. The first line imports a module called pyplot from the Matplotlib library. Matplotlib is a comprehensive library used for creating static, animated, and interactive visualizations in Python. The pyplot module specifically provides a simple interface for creating plots, similar to how plotting works in tools like Matlab. We rename matplotlib.pyplot to plt using the as keyword. We do this because instead of writing matplotlib pyplot every time, we can simply write plt.plot. This makes our code cleaner, shorter, and more readable. And you will see almost every data analyst use plt as the standard alias. So whenever you use plt, just remember it's our plotting tool. The second line imports a powerful visualization library called Seaborn. Seaborn is actually built on top of Matplotlib. Think of it as a higher level library that makes plots look more attractive and easier to create, especially when working with dataset. We rename it to SNS again. This is just a common convention in the data science community. So why are we importing Seaborn if this is a Matplotlib video? This is a great question. Because Seaborn works together with Matplotlib, many times we use Seaborn for better styling, themes, and statistical plots, while Matplotlib gives us full control over customization. You can think of it like Matplotlib is for full control and flexibility, whereas Seaborn is for better defaults and cleaner designs. And since Seaborn is built on Matplotlib, understanding Matplotlib first makes everything else much easier. Next, we will be loading a real dataset. So let's break this down step by step. In the first line, we are using Seaborn to load a built-in dataset called tips. Seaborn provides several built-in datasets that are perfect for practice and learning. The tips dataset contains information about restaurant billings, including total bill amount, tip amount, gender of the customer, whether the customer is a smoker, day of the week, time, lunch or which is either a lunch or dinner, and the party size. So essentially, this is a real world transactional data from a restaurant. We store this dataset in a variable called tips. Think of tips as a table, specifically a pandas data frame where rows represent individual records and column represents features. This is important because most real world data analysis involves working with data frames. The second line dot head function displays the first 5 rows of the dataset by default. Because before visualizing a data, we need to understand what it looks like. This step helps us to check the column names, understand what kind of values we are dealing with, verify that the dataset loaded correctly. This is a very important habit in data analysis. Always inspect your data before jumping into visualization. Next, we'll create a line chart with Matplotlib. So in the first step, we are creating a simple Python list called daily sales. This line represents sales value over 5 days. This is a simple data set, but it will help us focus on understanding how plotting works. In real world projects, this data would usually come from a CSV file, Excel file, or a database. In the second step, we are plotting the line. The plot function draws a line connecting the data points. Since we provided only one list, so Matplotlib automatically uses the value in daily sales for the y-axis, uses the index position for the x-axis. So internally, it's plotting like 0 for 120, 150, 2 for 170, 3, 140 for 180 and so on. That's why even though we didn't explicitly provide days, the graph still works. This is very important to understand. If you don't provide X values, Matplotlib automatically generates them. In the third step, we are adding the title. This is this title is an extremely important step in data visualization. A graph without a title forces viewers to guess what it represents. A good title immediately communicates the purpose of the chart. Here, daily sales trend clearly tells us what we are looking for, how the sales changed over time. The last step is labeling the axis. With the X label is days, whereas the Y label is sales. Axis labels are crucial for clarity. Without them, a chart can become confusing very quickly. In professional dashboards and reports, missing axis labels is considered a major mistake. Then we are displaying the plot. This line actually displays the plot. Think of it as telling Python, okay, now render everything and show the graph. Without plt.show, especially in scripts, the graph may not appear. This is the final step that makes your visualization visible. Next, we will be creating a bar chart. So, in the first step, we are creating a list of categories. These represent different product types in a business, which is electronics, clothing, and food. This will form our x-axis because bar charts are commonly used to compare different categories. In the second step, we are creating the revenue data. This list represents the revenue generated from each category. So electronics is 50,000, clothing is 30,000, and food is 20,000. These values will appear on the y-axis. The key idea is that the number of elements in both lists must match. Each category must have a corresponding revenue value. Next, we are creating the bar chart. This is the main plotting function. The bar function creates vertical bars. The categories creates the x-axis labels. The revenue is the height of the bars. Matplotlib automatically matches each category with its revenue and creates a bar for each one. Bar charts are ideal for comparing different groups side by side. Then we are adding titles and label. A title for the context, x-axis label and y-axis label. This ensures the visualization is clear and professional. Without labels, viewer might not understand what the bars represent. And finally, we are displaying the chart using plt.show. This renders the chart and displays it on the screen. Always remember that plotting function prepares the graph, but plt.show displays it. Let's create a scatter plot with Matplotlib. We are using the tips dataset that we loaded earlier. Here, the total bill stands for the total bill amount paid by the customers, and the total tips stands for the tips that are given by customer. So essentially, we are trying to see, is there a relationship between the total bill and the tip amount? This is exactly the kind of questions scatter plots are designed to answer. In the next step, we are creating the scatter plot. The scatter function creates individual data points on the graph. So x-axis represents total bill and y-axis represents tip. Each point on the graph represents one customer's record. For example, if a customer had a total of 20 and gave a tip of 3, that becomes 1 point at 20,3. Unlike line charts or bar charts, scatter plot helps us understand the relationship between two numerical variables. Then in the next step, we are adding title and axis labels. The title clearly tells us what we are analyzing. Axis label makes the chart readable and professional. Always remember that a good visualization should be understandable even without explanation. Then finally, using plt.show, we are displaying the plot. Without this line, especially in script-based environments, the plot may not appear. Next, we'll customize the plot in Matplotlib. Now that we know how to create a scatter plot, we will now make a more readable and professional scatter plot by adding some customization. You can see in the first step we are creating the scatter plot. Just like we are plotting total bill at the x-axis and tip at the y-axis. Each point represents one customer's bill and the tip they gave. This helps us visualize the relationship between two numerical variables. Then we are adding the titles and label. In the title, we are adding bill versus tip. Y-axis label is represented by total bill, and the x-axis label, and y-axis label is tip. Even though this looks simple, these lines are extremely important. Professional data visualization is not just about plotting points; it's about clarity. Then we are adding a grid. This is a new addition now. The grid true function adds background grid lines to the plot. This is useful. The grid line makes it easier to estimate values, compare data points, read the graph more accurately. For example, if you want to check whether a tip is close to 5 or 6, the grid helps you visually align it with the axis. Small enhancements like this significantly improve the readability. Then we display the plot. As always, this render and displays the final visualization. Next, we'll add multiple lines and a legend. Now we'll learn how to plot multiple lines on the same graph and use a legend to distinguish them. First, we are plotting the first line. Here we are plotting a simple line with values 1, 2, 3. Since we didn't specify the x values, Matplotlib automatically uses 0, 1 and 2 as the x-axis. The most important part is the label which we have given it as sales. This label does not immediately appear on the graph. It is stored so that the legend can use it later. So this line represents the sales data. Then we plot the second line. This time the values are decreasing 3, 2 and 1. We again provide a label which is profit. Now the graph contains two lines, one increasing sales and one decreasing which is the profit. By default, Matplotlib automatically assigns different colors to each line so they are visually distinguishable. Then we add the legend. The legend is the place where the labels we defined earlier become visible. The legend creates a small box on the graph that shows which line represents sales, which line represents profit. Without a legend, viewers wouldn't know which line is which. Whenever you plot multiple lines, always use a legend is the best practice in data visualization. Then we add the title. The title clearly explains what the graph is comparing. Title provides context, the legends provide clarity. Together they make the visualization understandable. Then using plt.show we display the plot. Now let's learn how to control the range of values shown on an axis by setting axis limits in Matplotlib. So let's break this down step by step. First is plotting the data. We are plotting the daily sales list again. Matplotlib automatically uses the index value for the x-axis and uses the sales value for the y-axis. By default, Matplotlib decides the y-axis range automatically based on the data. Then we set the y-axis limits. This is the key part. The y-lim stands for the y-axis limit. Here we are manually setting minimum value and the maximum value. The minimum value is 100, the maximum value is 200. This means that the graph will only display values between 100 and 200 on the y-axis. Even if the data goes slightly outside the range, the view will be restricted. Then we add the title. The title clearly indicates that we are looking at a zoomed in version of the sales trend. Whenever you adjust axis, it's a good practice to reflect that in the title so that viewers understand the context. Finally, using plt.show, we display the plot. Now let's explore something very powerful, plotting directly from Panda style data frame. So let's understand this step by step. In the first step, we are grouping the data. Here, we are grouping the data based on the day column. That means we are separating the data into groups like Thursday, Friday, Saturday, Sunday. Grouping is extremely common in data analysis because we often want to compare categories. Then in the next step, we are selecting a column. After grouping by day, we are selecting the total bill column. So now we are focusing only on total bill amounts within each day group. Then in the next step, we are calculating the mean. This calculates the average total bill for each day. So internally, we have something like Thursday, Friday, Saturday, Sunday, which each displays the average bill. This transforms raw data into summarized insights. And summarizing data is one of the most important skills in analytics. Then the next step, we are plotting directly using the dot plot function. This is where it gets interesting. Instead of using plt.bar manually, we are creating a dot plot directly on the group result. Since pandas integrates with Matplotlib, it automatically uses the group name, which is days, as the x-axis labels and uses the calculated mean values as bar heights. And it creates a bar chart because we specified kind equals to bar. This is Panda style plotting and is very convenient. Behind the scenes, it still uses Matplotlib. Then in the next step, we are adding the title and Y label. We add a clear title and a Y-axis label. Notice we didn't manually define the X-axis label. Pandas automatically uses the column name day as the X-axis. Then finally, using plt.show, we display the plot which renders the final visualization. Now let's look at another common type of visualization, the pie chart. I will write the code now and help you understand it clearly. In the first step, we are creating a data. The list represents the numerical values. This could represent anything, for example, market share, population percentage, sales contribution. Each number corresponds to a category. The list contains category labels. So 36 represents Germany, 34 France, 30 Italy, 40 Brazil. The key rule is the number of labels must match the number of values. Then in the next step, we create the pie chart. The pie function creates a circular chart divided into slices. Each value in X determines the size of the slice. Each label in Y is displayed next to the slice. The bigger the value, the larger the slice. Matplotlib automatically calculates the proportion of each slice relative to the total. So the pie chart visually represents a part of the whole. And in the next step, we display the chart using plt.show function. This renders and displays the pie chart. Pie charts are best when used to show proportion or the number of categories is small or whenever you want to highlight contributions to a total. And that's a wrap on the Matplotlib basics. Today you have learned how to create line charts, bar charts, scatter plot, pie charts, customizing the visuals, adding legends, controlling access limits, and even plot directly from a group data. But remember, watching is not enough. The real learning happens when you open your notebook and start experimenting. You can try to change the values, you can modify access limits, you can add color, combine multiple plots. The more you practice, the more confident you will become. Matplotlib is the foundation of data visualization in Python. Once you are comfortable with it, learning advanced libraries become much easier. If you found this video helpful, make sure to like the video and subscribe to the channel for more beginner friendly data analysis tutorials. I'll see you in the next lesson.